Somewhere between the last star you can see with your naked eye and the absolute void of open galactic space, a machine is dying. And it is dying in the middle of telling us something we were never supposed to hear. Something so structurally strange, so fundamentally at odds with every model, every equation, every confident declaration science has made about the universe beyond. Our solar system, that the engineers receiving its transmissions, have begun doing something that brilliant people at NASA almost never do. They have stopped explaining and started listening, because right now, at this precise and unrepeatable spacecraft, the size of a small car built from aluminum and ambition in 1970s circuitry, is transmitting data from 15 billion miles away, data that does not match what it is supposed to be transmitting, data that contains rhythms where there should be chaos, structures where there should be emptiness, and magnetic signatures that point toward something waiting in the dark between stars that our physics has no name for. And the most terrifying dimension of this story is not the anomaly itself, it is the clock. Because the power is failing, the instruments are shutting down one by one, and the window to understand what Voyager 1 is screaming back at us from the edge of the known universe is closing, not in years, not in decades, but potentially in the next few months. And when it closes, it will close forever, and we will be left standing here on this pale blue rock with our telescopes and our theories and our profound, humbling ignorance, staring at the coordinate in space where our greatest explorer fell silent mid-sentence, wondering whether what it found out there was the most important discovery in the history of science, or whether we simply ran out of time to understand it before the last light went out. To understand why this matters so deeply, why the people at NASA's Jet Propulsion Laboratory are choosing their words with the kind of surgical precision that tells you they're terrified of saying the wrong thing, you have to go back to where this story actually begins. Not in 1977 when Voyager 1 launched, not in 2012 when it crossed into interstellar space, but in the fundamental assumptions that an entire field of science built its understanding upon. Because science does not fail all at once, it fails slowly, quietly, through accumulated anomalies that each seem explainable, until the day you step back and realize the explanation stopped working a long time ago, and nobody said anything, because nobody wanted to be the person in the room who admitted the map was wrong. The Heliosphere, the vast magnetic bubble generated by the sun that surrounds our entire solar system and everything in it, was supposed to have a clean, well-defined edge, a boundary called the heliopause, where solar wind pressure and interstellar pressure reached equilibrium, and the sun's influence simply stopped like the edge of a soap. Bubble, thin and clear and precise, and for decades that model held. It made mathematical sense. It fit the data from our telescopes and satellites. It was the kind of clean, elegant picture that physics produces when it is working correctly. And then Voyager 1 physically arrived at that boundary and drove through it, and the clean, elegant picture began to tear at the seams, because when the data came back from the crossing in August 2012, the heliopause was not a thin line. It was a zone, a thick, turbulent, chaotic, magnetically complex zone where solar and interstellar fields were tangled together in configurations that no model had predicted, and the scientists who received that data did. What scientists do, they updated the models, they wrote papers, they held conferences, and they moved forward. But moving forward meant carrying with them a quiet new uncertainty, the recognition that the boundary they had studied for decades from the inside was nothing like what they had imagined it would be, and that the space on the other side of it, the interstellar medium, the cold, dark ocean between stars, was about to reveal itself to be something far stranger than the textbooks had prepared them for. The interstellar medium is not empty, and this point cannot be overstated, because the popular image of deep space, the void between stars, is one of absolute nothingness, a vacuum so complete that nothing could possibly move through it or exist within it, but that image is wrong in ways that matter enormously for what Voyager 1 is currently measuring, because the space between stars is filled with a tenuous plasma, a diffuse fog of charged particles and magnetic fields and cosmic radiation, streaming in from supernovae and galactic cores and processes so vast that our entire solar system is nothing more than a tiny disturbance moving through them. And in late 2020, Voyager 1 gave humanity its first direct confirmation of this when its plasma wave subsystem detected something that stopped scientists cold. A persistent steady hum, a vibration in the interstellar plasma that had been there all along. The universe between stars singing at a frequency we had never been positioned to hear before, and that detection was not just scientifically significant, it was philosophically staggering, because it meant the space our spacecraft was moving through was not passive, it was active. It had structure, it had dynamics, and it was capable of producing signals that an instrument designed to measure charged particle vibrations could detect and record, and that realization set the stage for everything that followed. Because if the interstellar medium has a voice, if it has density and magnetic architecture and behavioral patterns, then anything anomalous within it is not just an instrument malfunction. It is potentially the first measurement of something real. What happened next is where the story shifts from scientifically interesting to genuinely disturbing, because starting in 2020 and accelerating through 2024 and into 2025, the anomalies began, and they did not behave the way anomalies are supposed to behave when the explanation is simple. Voyager 1's magnetometer registered an abrupt and significant jump in the intensity of magnetic fields embedded in the interstellar plasma. Simultaneously, its plasma wave detector registered a corresponding rise in plasma density, and scientists reached for the most available explanation: solar events, surges of plasma from the sun colliding with the outer boundaries of the heliosphere and sending pressure waves reverberating outward into interstellar space like shock waves from a massive detonation. And for a while that explanation held. Earlier, anomalies of a similar character had appeared and faded. They had peaked and then returned to baseline, and the math for a solar origin worked. The timing was consistent with known solar activity cycles. The model absorbed the anomaly and moved on. But then, the anomalies that began in 2020 did not fade. They persisted. They deepened. They continued well past any reasonable timeline for a solar origin wave to dissipate. And some of the mission scientists began to say quietly and then less quietly that the sun might not be the source, and that sentence, spoken carefully by serious people who do not use it lightly, is perhaps the most significant sentence in the entire history of this mission. Because if the sun is not generating these magnetic disturbances, if they are not echoes of solar activity bouncing back from the edge of the heliosphere, then something else is generating them, something that exists in the interstellar medium itself, something that Voyager 1 is moving through and measuring from the inside, something with no entry in any catalog of known astrophysical phenomena. And that is not speculation, that is the logical conclusion of the data, which is precisely why the language coming out of JPL has become so extraordinarily careful. Because when you are a scientist and the data is telling you something that has no name and no classification and no framework within which to understand it, the responsible thing to do is say so without saying everything you're thinking. And what these scientists are thinking is something that does not fit comfortably inside the boundaries of professional scientific communication. In early 2025, the situation escalated in a way that changed the texture of the entire conversation, because engineers tracking Voyager 1's data stream noticed something that had never appeared before in the nearly 5 decades of this mission: the plasma wave. Subsystem, the instrument designed to detect and measure the vibration of charged particles in the interstellar medium, began reporting a rhythmic pulsing, not a random fluctuation, not a noisy signal with statistical variation, but a structured rhythmic pulse occurring at regular intervals, a pattern, a repetition, a beat, in a place where, according to every model and every theory and every expectation built up over 50 years of astrophysics, nothing should have a beat, because rhythm implies structure. Structure implies organization, and the interstellar medium between stellar systems is not supposed to be organized. It is supposed to be the opposite of organized. It is supposed to be the thermodynamic endpoint of stellar processes, the cold, scattered remnant of cosmic events so enormous and so ancient that all their energy has long since dissipated into uniform background noise. And yet here is Voyager 1, 15 billion miles from Earth, moving through that supposedly structureless medium, and its instruments are detecting a rhythm, a regularity, a pulse that repeats, and the engineers and scientists receiving this data are doing something you almost never see in formal scientific reporting. They are being honest about not knowing what it is, an honest uncertainty from brilliant people who have dedicated their lives to understanding exactly this kind of data is one of the most unsettling things you can encounter, because these are not people who are confused about simple things. These are people who understand interstellar plasma physics at a level most of us cannot approach, and they are saying they do not have an explanation. And that absence of explanation, that silence where a confident scientific account should be, is louder than anything the spacecraft itself is transmitting. Now there are mundane explanations on the table, and they deserve to be taken seriously, because the history of science is full of dramatic anomalies that turned out to be instrument failures, and Voyager 1 is an ancient machine operating in conditions that would destroy most modern technology. Within hours, it has been exposed to radiation so intense and so prolonged that its very circuitry has been physically altered at the atomic level. Its power systems are degrading steadily. Its memory chips have been struck by high-energy cosmic particles that corrupted data streams for months. In November 2023, one such strike caused the spacecraft to transmit pure gibberish for weeks before engineers managed to diagnose the problem and develop a patch uploaded across a 23-hour communication delay. And this is the impossible epistemic position that the mission scientists currently occupy. They are trying to determine whether an anomalous signal is a discovery or a malfunction using instruments that are themselves potentially malfunctioning. They are trying to read a message written on paper that is actively burning. And the only way to separate a genuine measurement from a hardware artifact is through cross-instrument confirmation, through the agreement of independent sensors detecting the same phenomenon through different physical mechanisms. And here is what makes the current anomalies so difficult to dismiss. The plasma wave subsystem and the magnetometer, two fundamentally different instruments measuring different physical quantities through different detection methods, are agreeing with each other. They are both reporting anomalies that are consistent with each other and inconsistent with baseline expectations. And when two independent sensors built on different principles simultaneously report the same impossible thing, the probability that both are malfunctioning in perfectly complementary ways drops to something very close to zero, which means what they are detecting is almost certainly real. And what they are detecting is something that science does not currently have a name for. The leading hypotheses among the scientists who are publicly willing to discuss this fall into several categories, each more extraordinary than the last. And the fact that extraordinary hypotheses are now the leading candidates tells you everything you need to know about how far outside normal experience this data falls. The first and most conservative possibility is that Voyager 1 has encountered a region of the interstellar medium that is structured differently than our models. Predicted, perhaps a magnetic filament, a dense thread of organized magnetic field left behind by some ancient stellar event, a supernova perhaps, or a collision between stellar winds from neighboring star systems. These filaments are known to exist in theory and have been detected at large scales through radio telescope observations, but Voyager 1 would be the first instrument to physically pass through one, the first to measure it from the inside rather than from astronomical distances. And if that is what the rhythmic pulsing represents, the resonant vibration of a magnetized filament being excited by the spacecraft's passage through it, then we are looking at the first direct in situ measurement of a cosmological structure that has never been sampled at close range, which would be scientifically extraordinary. The second possibility is more unsettling. The Voyager 1 has encountered an additional boundary layer beyond the heliopause, a previously unknown transition zone where the local interstellar medium interfaces with some larger galactic structure, a kind of nested boundary that our heliospheric models had no reason to include because we had no data suggesting it existed. And the implications of that are significant because if the space our solar system is moving through has additional layers of structure that we did not know about, then our understanding of the galactic environment we inhabit is materially incomplete. And the radiation and magnetic field conditions that any future interstellar mission would encounter would be different and potentially more hazardous than we currently calculate. And then there is the third possibility, the one that sits at the very edge of what scientists are professionally permitted to entertain, which is that what Voyager 1 is detecting in the interstellar medium is not explicable by any known natural process. Not a magnetic filament, not a boundary layer, not a resonant plasma structure, but something whose organizing principle we do not yet possess the conceptual framework to understand. And that sentence is not science fiction. It is the honest outer boundary of what the data currently permits. The honest acknowledgement that science has edges, and that Voyager 1 may have physically reached one. The urgency of this situation, the dimension of it that most coverage fails to convey with appropriate seriousness, is the power problem. And to understand the power problem you have, to understand something about how Voyager 1 stays alive, the spacecraft is powered by 3 radioisotope thermoelectric generators, devices that convert the heat produced by the natural radioactive decay of plutonium-238 into electrical power, and they worked extraordinarily well. They powered the spacecraft through its entire mission, through the outer solar system, through the Heliosphere, through the heliopause crossing, through the anomalies of 2020, but radioactive decay does not stop, and the power they produce decreases by roughly 4 watts per year. 4 watts that sounds trivial until you realize that 4 watts per year over nearly 50 years adds up to a spacecraft that is operating on a tiny fraction of the power it had at launch. And engineers have responded to this power reduction with a strategy that can only be described as controlled sacrifice, systematically shutting down every non-essential system, every heater, every instrument package that is not absolutely critical, making the kind of decisions that no engineer wants to make, choosing which eyes to close forever. And as of late April 2026, the result of those decades of managed shutdown is this. Only 2 instruments remain operational on Voyager 1. The plasma wave subsystem and the magnetometer, 2 instruments, 2 remaining windows onto the most alien environment humanity has ever directly measured. And those 2 instruments, the last 2 survivors of a once comprehensive science suite, are the exact instruments reporting the anomalies that nobody can explain. And there is something almost unbearably poignant about that arrangement. The universe waited until the spacecraft had almost nothing left before showing it something that required everything. The communication delay adds a layer of tragedy to this situation that compounds every other difficulty. Because Voyager 1 is so far away that radio signals traveling at the speed of light take approximately 23 hours to make the one-way journey from Earth to spacecraft, which means that when the team at JPL sends a command, they will not know if it was received and executed correctly for nearly 2 full days. And when Voyager 1 transmits its data, the scientists who need that data to understand what is happening out there will not see it for 23 hours. And this creates a rhythm of interaction that feels less like operating a spacecraft and more like conducting a conversation with someone standing on the far side of the world who can only respond once a day. A conversation conducted across a void so immense that even light, moving at 186,000 miles per second, needs almost a full day to cross it. And when you understand that, when you feel the weight of that delay in your bones, the situation becomes viscerally real in a way that numbers alone cannot convey, because the anomalies are happening right now. They are happening in real time 15 billion miles away. And the people trying to understand them are receiving the reports of those anomalies 23 hours after the fact, analyzing data that by the time they see it is already nearly a day old, from an instrument that by the time they respond to it is drifting further into the anomalous region with every passing hour. And there is nothing to be done about that. It is the physics of distance. It is the price of being the first to go somewhere. No one has gone before. And yet, and this is the part that demands to be held alongside everything else, the signal has not faded yet. It is still arriving. Right now, as you watch this, a stream of data is traveling across 15 billion miles of interstellar space at the speed of light, carrying measurements of a magnetic and plasma environment that no instrument has ever sampled before. And some of those measurements are things that the best astrophysicists on Earth are genuinely unable to explain. The rhythmic pulsing continues, the magnetic direction changes persist, the high-energy particles surges with no identified source keep appearing in the data and the pattern they form together, the accumulation of anomalies that each individually might be dismissed as noise, but together constitute something that looks more and more like signal, is growing more coherent and more difficult to explain away with every passing transmission, because this is how discovery actually works, not as a single dramatic revelation, but as an accumulation, a slow building of evidence that at some point crosses a threshold past which dismissal becomes harder than acceptance. And the evidence from Voyager 1 is crossing that threshold. The scientists know it. They are saying so in careful language that preserves their professional credibility while acknowledging that the data is pointing somewhere unprecedented. And what makes this moment historically significant is not just the anomalies themselves, but the fact that they are being measured at all, that the instrument is still there, still transmitting, still adding data points to a pattern that is taking shape in real time, that the most distant human-made object in existence is still doing science from a place that no model fully anticipated and no theory fully describes. The broader implications of what Voyager 1 is detecting stretch far beyond the immediate mystery of the anomalies themselves, because if the interstellar medium in the region our solar system is currently moving through contains structures and dynamics that our models do not account for, then everything we have planned on the basis of those models needs to be revisited. The radiation environment calculations for future deep space missions, the magnetic field models that determine how interstellar particles interact with spacecraft shielding, the boundary condition assumptions that underpin our understanding of the heliosphere's protective role for life on Earth, all of these are built on a model of interstellar space that Voyager 1's data is actively challenging. And the challenge is not theoretical, it is empirical. It is coming from direct measurement by an instrument physically present in the environment being modeled, which is the highest possible epistemic authority in science. You cannot argue with a sensor that is there. You can only try to understand what it is telling you. And what it is telling us is that the space between stars is weirder, more structured, more dynamically complex than we built our plans around. And that matters for every mission we will ever send beyond the Heliosphere. It matters for the breakthrough starshot concept and the interstellar probe proposals and the long-range vision of humanity as a spacefaring civilization eventually moving beyond its home system. All of those futures rest on assumptions about the interstellar medium that a dying spacecraft is currently in the process of revising, and the revision is incomplete because the spacecraft is dying. And that incompleteness is not a footnote. It is a crisis. There is also the question of what comes next, and the answer to that question is simultaneously hopeful and sobering, because humanity has not stopped thinking about interstellar exploration. There are concepts on paper and proposals in development for a next-generation interstellar probe, something faster, better instrumented, capable of reaching the distances Voyager 1 has traveled in a fraction of the time, and eventually such a mission will be built and launched. And the data gap that Voyager's shutdown will create will be filled, but the gap itself will be real, and it will be long, measured not in years, but in decades, perhaps in the careers of scientists who are currently undergraduates. And in that gap, the questions Voyager 1 is raising will sit unanswered. The The anomalies will remain classified as anomalies rather than discoveries. And the universe will continue keeping the secrets that a small dying machine came at breathtakingly close to, unlocking before the power gave out. And there is no comfort in the plans for future missions when you are watching the only current source of in situ interstellar data approach its final transmission. Because the future mission, however magnificent, cannot go back in time to capture the measurements that Voyager 1's failing instruments are taking right now. This data, these readings, this particular slice of the interstellar medium at this particular moment will only ever be measured once by this spacecraft. And what it manages to transmit before shutdown is all that will ever exist of this chapter of cosmic exploration. What Voyager 1 represents, stripped of all technical language and reduced to its essential human meaning, is the farthest reach of our curiosity, the physical manifestation of the need to go and see for ourselves, to not accept the model, to not trust the simulation, to send something real into the real environment and measure what is actually there, and what is actually there has turned out to be stranger and more complex and more mysterious than the people who built this spacecraft could have imagined when they bolted the golden record to its frame and aimed it at the outer solar system and set it loose into the dark. And now, nearly 50 years later, it is dying in the middle of a discovery that it does not have the power to complete, transmitting its final measurements from a coordinate in space that will not be visited again in the lifetimes of most of the people watching this. And the measurements it is sending back are saying something that we are only beginning to have the language to understand. Something about the structure of the space between stars. Something about the forces operating at the frontier between our solar neighborhood and the open galaxy. Something about the universe that we did not know and might not know again for a very long time. And the question that will define the coming months as the power continues its relentless 4-watt per year decline and the instruments approach their final shutdown is whether enough data arrives before the silence to answer the question that the data itself is raising, whether we will understand what Voyager 1 found before Voyager 1 can no longer tell us, whether the most important discovery in the history of space exploration will be completed, or whether it will end the way so many great human stories end, not with a conclusion, but with a question, hanging in the dark, unanswered, permanent, and profound, because the silence is coming, and when it have all the answers, and we will spend the rest of our scientific lives wondering what a small machine was trying to tell us from the edge of everything we know.